operations on functions. This stuff used to be in like pure 20, so it's like grade 11 stuff. Only it's like on steroids, I guess. It's grade 11 stuff. So we've learned about various types of functions. We've done polynomial functions, radical functions, rational functions, absolute value functions, trigonometric functions, exponential functions. We've done a lot of functions, right? We will now learn how to combine functions through the operations of addition, subtraction, multiplication, and division. Given two functions, f of f and g of x, there's some difference, product and quotient, which is a fancy way of saying addition, etc., are described by the notation shown. So if you see f plus g of x, that means f of x plus g of x. Okay, notation. If you see f minus g of x, it means f of x, right, like evaluate that and subtract from it the evaluation of g of x. If you see f dot g, solid dot, multiply, right, or just fg, which means multiply, of x, it means take f of x times g of x. And if you see f over g of x, it means f of x divided by g of x. So what's special here then? No, x could be 0. G of x cannot be 0, right? So if we're going to divide, we know we can't divide by 0. Okay, so that's the notation. Okay, so here we have the graphs of the continuous functions y equals f of x and y equals g of x. And you know the g of x is special, right? It starts at 1 and goes down, whereas f of x has arrows on both ends. It's defined for all elements of the domains. So what's f plus g of 4? All right, so right now we could be thinking, okay, so that's f of 4 plus g of 4, right? That's your first thought. And what's f of 4? F of 4 is 3. What's g of 4? G of 4 is negative 4. 3 plus negative 4 is negative 1. What's f minus g of 3? So I see that, I think, oh, I got to do f of 3 minus g of 3. F of 3 is 4. G of 3 is negative 2. 4 minus negative 2 is 6. G minus f of 3. Okay. So you shouldn't need me now, right? You should just be able to kind of fire through the rest while I work on the rest of my lunch here.
We're all wandering back and forth. We're still in the fight. Well, are we both full?
Oh, we already worked on that, right?
Mm-hmm.
Just glance up occasionally and let me know if I messed up. I'm not trying to.
F of x isn't negative 12 over negative 10?
F of 7, you're right. That was 5/6 of the way to 6/5. Okay. I'm not trying to mess up, but I will. So. Three. Okay, so finish that bit off, check your answers, correct my mistakes. Or your mistakes, don't always assume you made the mistake.
What does the D&E stand for?
Does not exist. Whatever DNR, do not resuscitate. Which apparently they ignore. I've heard a thing on CPC. When you're a doctor, don't ignore that stuff. People want to die, they want to die. You know what I'm saying? No.
So what is your
Okay. By then we'll have assisted death.
So does it
Hmm.
does it want just D&E? Do you have to write it?
Does not exist. You got to say it doesn't. We can't do it, right? Because this is not defined. There is no G of 0, right? 0 is not in the domain of G, so you can't. You know the Heimlich? Have some basic first aid when you doctor. Just checking. Okay, need the medical student for a day thing, right? State the values of x so that f times g of x is equal to 0. Okay, so think about it. This means f of x times g of x equals 0. So what does that mean? Either out loud, either f of x is equal to 0 or g of x is equal to 0. Okay, what makes f of x 0? So 1 and 5. And what makes g of x 0? 2. Okay, so the values of x? 1, 2, 5. Okay, this is about the last time that I'm going to do this stuff. Right? Well, I kind of have to do this, but I won't explicitly write this out. Like I'll just go from here to here, kind of thing. Right? Okay. State the domain of f plus g of x. So what's the domain of f plus g of x? Which is f of x plus g of x. So x is greater than or equal to 1. That's going to be kind of a common theme in this, right? Because g is only defined when x is greater than or equal to 1. So what if I want to do f of x, f minus g of x? F minus g of x, what's that domain? Greater than or equal to 1 is the exact same thing, right? Just, as long as it's defined, right? If I'm adding or subtracting, as long as there is a value for f of x or g of x, then you can do it. So x greater than or equal to 1 or 1. F times g of x. Any restrictions there? No. So as long as x is greater than or equal to 1, right? So does it matter if either of those are 0? No, you're multiplying. It's just the product will be 0. F divided by g of x. Okay, now what? So what can't be 0? G of x can't be 0. What other restriction is there on g of x? It's greater than or equal to 1, but it can't be 0. Okay, so what are we going to say? X is greater than or equal to 1, but it's 2. No. But it cannot be equal to 2, right? So we have to restrict that. X can't be 2. In interval notation, 1 up to 2.
Shouldn't it be g of x can't be equal to? Because f of x can't be 2. But g of x can't
No, it's x can't be 2. If x is 2, g of x is 0. If g of x is 0, we're dividing by 0. The restriction is g of x can't be 0. Okay? But the domain is that x can't be 2. right? That's when g of x is 0, right? So we know that x has to be greater than or equal to 1. That's just common anywhere because we've used g of x in all of them. X has to be greater than or equal to 1 because it's not defined otherwise. In this particular case, g of x can't be 0, which means x can't be 2. So the restriction is on the x, right? And how do you do an and from 2 to infinity. Okay, so this,
Square bracket.
where? Not on here. So we can't include 2. Not here, and not here. I'm finally learning, right? Infinities cannot, or negative infinity has to have an open parenthesis or closed parenthesis. G of f of x can't be 0, so what are we going to say? So x, first of all, x has to be greater than or equal to 1, right? Because that's the overarching restriction. But then when was f 0? 1, okay, so now it's just greater than 1. And where else? 5, okay. So now it's just x is greater than 1, and x cannot equal 5. So x is greater than 1, oops, so now that's a round. Greater than 1, can't be 5. Okay, so greater than 1, so we have an open parenthesis. Can't be 5, close parenthesis. You can't be 5, open parenthesis, and to infinity. Okay, any questions on that? Everybody's good? All caught up? You're not writing anything down, so you're all caught up by definition. It's okay. The discrete functions, right? So they don't tell secrets about other functions, right? They're discrete. It's either that or they have individual points. I forget which. Y equals h of x and y equals m of x. Oh, they're just defined with points. Okay. Are shown below. So h, we have -2, h. Now think of functions as machines, right? Functions of machine. You drop a value in, you turn the crank. I should bring my little coffee thing with the crank. It's got a nice little crank that you can, and it's got a little spout you can drop stuff in. I should run and get it, but I'm not going to. So, I should.
It's necessary, yes.
All right, let's pause. They can't see it, but you should have been here. So this is the function. You drop a number in the top, right in there. You turn the crank, and it pops out the bottom, right in here. And that's the output. So it has an input. So function machines have an input. In this case, what are the allowable inputs to h? What can I drop in here? So -2, -1, 0, 1, 2. Can I drop a 7 in here? No, it'll jam it up, right? We don't want to do that because it's expensive. So, it's not cheap. Does anybody know, what do you think this is? It's a coffee grinder. Right? So you drop the beans in. Oh, I did say that, didn't I? Which means the people who didn't know that are like the people who got to that question on the test and said, I can't do this, even though it was on fall 2012, the exact same question. Right? Feel embarrassed. Don't worry, I won't point out who you are. I don't actually know who did or didn't do it. Okay, yeah, that was somebody else. Evaluate each of the following. So what does h plus m of 4 mean? H of 4 plus m of 4. Okay, what's h of 4? So you want? I'll write it out. Just so h of 4 plus m of 4. What's h of 4? -11. What's m of 4? 3. What's -11 plus 3? -8. M minus h of 0. Okay, so do we need to write this out anymore? You good? So we'll just go to the numbers. What's m of 0? Serious? Come on, let's get this right. What's m of 0? Okay, when I say m of 0, where are you looking for the 0? The x value, right? If you look here, then this is equal to your mark at the moment on that question. Right? It's like, yeah, no, you're looking in the wrong place. So m of 0 means the input, the thing that gets dropped into here is the x value or the first coordinate of the ordered pair. That's your input. Okay? So m of 0 is -3 minus h of 0. Here we do that expressly. What's h of 0? 2. Negative 3 minus 2 is? Okay. H minus m of 3. Okay, what do we got? Negative 8 minus,
There's no f value.
minus, there's no m value, right? I'm not allowed to drop a 3 into the m function. Okay, so what are we going to say about this? We'll say does not exist. Okay, doesn't exist. You can't do it, right? You can't put that in. Okay, what's h times m of 2? Okay, so that's equal to h of 2. Okay, so try the rest of these three. You should be able to work your way through that, right? Go to my lunch. Hmm. Okay, so check these. Agree, agreed? Disagree, agree, disagree. We can't agree to disagree. Math, you can't agree to disagree. Okay. You have to get into much higher levels of math before you can agree to disagree, right? Because it's like, well, nobody's really sure. So. All right, state the domain of. So if I want to add h of x and m of x, what are my allowable inputs? So what x values can I put in? I'm going to shrink this a smidge.
So
So
what's
like,
the maps that are both in there?
the ones that are both in there. Okay, who's both in there?
Like let's say -2. They're both-
So let's say -2. Okay? What else should we say? We should say 0. What else should we say? 2 and 4. So what's the characteristic? That x value has to what? Got to be in the domain of h and also in the domain of m, right? It's got to belong to both domains. What if I want to do h minus m of x? Same. I shrunk the page, so honey, I shrunk the page, so I can't fit the h times m of x. Same. H divided by m of x. Okay, so we're still looking at, it has to belong to h and it has to belong to m, right? So we're looking at -2, 0, 2, and 4. But then we say, but what? But m of x can't be, no. M of x can't be, no, m of x can't be, no. M of, look, h of x divided by m of x. M of x can't be 0, so x can't be, well, yeah, you might have been, but other people were saying 2. I kept hearing 2. M of x can't be, not loud enough. M of x can't be 0, so x can't be 2. So the domain is -2, 0, and 4. Sorry, the louder voices amongst you kept saying 2. So until everybody said 0, I wasn't going to let you go. No, you can't go on. But I'm saying it doesn't matter. Say it louder. M of h of x. So h of x can't be 0. So x can't be, nothing h can't be, right? There is no output, right? There's no output of 0. So h of x just can't be 0 no matter what. So what's our domain? Come on, would you put your brain in gear?
Okay.
What's
What's your domain? The same as all the other ones except for this one. -2, 0, 2, and 4. Okay? So there's a restriction on this whole thing, right? Which is, if I'm going to do anything with h of x and m of x, add, subtract, multiply, divide, whatever, then the values have to be common, right? The x values have to be shared. Okay, and then we say, but if we're dividing, then if I'm dividing by m, I can't have this. So that comes out of the domain. If I'm dividing by h, I'm good. I can divide by any of those numbers. Yeah. I'm sorry to hear that. I'm sure, is it just for cleaning or something? That's not so bad. And what?
And a whitening.
And whitening. Ah, well, whitening is good.
Free whitening.
Huh?
Free whitening.
A free whitening.
Free whitening.
All right,
Pretty
so
sure
look,
free
you do this. Yeah. Before you walk in, okay, like do a selfie, right? And then when you come out, make sure the light conditions are the same,
Okay.
right? Because it just could be like, oh, this one's outside in the snow. Well, everything looks bright and white in the snow. Yeah. So just as you walk in, and then as you walk out, right? So same lighting conditions. I just want to compare, right? Objectively, and then you can show them to me, but not in any particular order, right? Just
And then,
randomly
yes.
choose and say, yeah, which one is after the white? Because we can't tell. Then you say, wow, no wonder it's free. It's obviously not worth anything. Like half the people said this was the after, and it's not. It was the.
I can take those results and do that.
Okay, good. Just do it in the chair while you're in the same light. Okay. We've settled that. Well, it's double blind, right? We don't know. He knows, but we don't know. Given two functions, f of x and g of x, the domain of their sum, difference, or product are all the values of x that are blank to both.
Belong.
What's a good word? Belong or are common to both. I'd go with common. The domain of the quotient are all the values of x that are common to both, but excludes values where?
Where the G?
Where what?
Oh, G.
Where g of x is equal to 0, right? We cannot say anything about x, right? We don't know what the x's are. We do know that the g of x can't be 0, right? And that's what we're going to say, right? That's why I said this 100 times, but somebody kept saying 2. No, that's the x value. 4 functions are given by, okay, let's go back. Zoom, page width. 4 functions are given by f of x is 4x squared minus 1, g of x is 2x squared minus 7x minus 4, h of x is 2x cubed minus 3x squared minus 8x minus 8, and p of x is negative 2x minus 1. What kind of functions are these?
What is it?
What are they called? Polynomial, right? These polynomial functions. Remember, we dealt with polynomial and rational and radical and exponential and logarithmic and absolute factor. These polynomial. Determine a simplified expression for each of the following and state the domain.
Six is edge.
So, we've got f plus g of x. What does that mean? F of x plus g of x. Okay, what's f of x? So it's like 4x squared minus 1 plus, what's g of x? 2x squared minus 7x minus 4. Okay. I put them in brackets only because occasionally there's a minus sign in here, and I want you to remember to distribute it through the brackets. So now I'll remove the brackets, but I'm not going to really. I'm just going to add them. So what do we end up with?
6x squared minus 7x minus 5.
6x squared minus 7x minus 5. Right? So instead of dropping a value into the F machine and cranking it, right, and then having to take that and find out it's now a different machine, put that value in there, crank it, right? Instead, we now have a machine that does both F plus G. So I just drop it in, one crank, done. Okay, so just keep going. And just remember, this letter changed here, right? It's not always F and G. There are 4 functions there.
We don't need to factor.
Why would you? That's not simplified. Factored form isn't simplified form. Right? Simplified is ax squared plus bx plus c. Factored is like, ooh, this is complicated. If it were equal to 0, it's useful to have a factored form. If it's not equal to 0, it's not useful. As a machine, I don't want factored form if I'm dropping in a value, right? I just want to square the x, multiply it by 6, multiply it by 7, subtract that, and subtract 5. Oh, And state the domain. Okay, what's the domain? X belongs to the reals, right? Where are we going to have domain problems? When we have quotients, right? So these are all polynomials. What's the domain of every polynomial function? X belongs to the reals. So if we add them, meh. Subtract them, meh. Multiply them, meh. But if you divide them, okay. So yeah, X belongs to the reals. Domain for this one, X belongs to the reals. And so on. Okay, so sorry, keep going. So what is this? This is I'm going to magically remove the brackets and simplify in one step. But just be aware if you have, if you find you make mistakes, right? Because this has to be a minus 4x squared and a plus 1. So I'm just going to keep that in mind as I do it. And if you find that you're having problems when you subtract one function from another, then just do an extra line, right, where you write it out explicitly. Negative 2x minus 7. And the domain is. Wait, I should leave that this. Now I gotta look on my sheet because I have no idea what P is. Okay, negative 8x cubed. Change things up. Oh wait, I know F and G. Oh, really? 6 terms? Ow, sore arm rings. Okay, so some stuff's going to disappear. I'll try to leave these up here. Oh, division. Division. Okay, so now we have a little more work to do, right? First of all, does this simplify? So I'm actually going to have to factor and see if I get a simplified form. Okay. times g of x. Oh, really? 2x cubed minus 3x squared minus. Alright, well, maybe let's do this one together because it's going to require some work.
Well,
I need a 0. Somebody find me a 0. For this.
Calling you out as a
Just go on your calculator, look in the table. Yeah, sure. So if there's a 0, I know it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, right? If there's an integral 0. Throw it in your calculator, go to the table, and you're looking from negative 8 to positive 8. Find me a 0. 4, huh? Yeah. Negative 2. 4 actually works as well. Okay. But negative 2 is probably the first one you might come upon. Doesn't matter, right? So 0 at, what would you like? 4 or negative 2? Doesn't matter. Negative 2. So I'm going to do x plus 2. And what do we got? 2, negative 3, 2, 4, negative 7, negative 14, 4, negative 8, 0. Okay. Like, I knew that had to be a 0 here, right? Okay. So we're looking at, now we factored this guy already, right? It's 2x plus 1 and x minus 4. And this guy is x plus 2 and 2x squared minus 7x plus 4. So now we got to factor this if we can, right? Oh yeah, that's a good bet, right? We know that x, having found that 4 was a. Okay, so here, let's do this. 2x plus 1, x minus 4, x plus 2, 2x, and x minus 4, right? Because we know that another 0 was at 4. What?
Yeah.
Oh, that's a minus. Oh, that's why we usually say minus 4. Oh, that's a minus? Oh, you're right. Yeah. Okay. Still, we know that there's a 0 at 4, so I can do an x minus 4 here, right? And that minus 4. So this will be 2x plus 1. Right? So 2x squared minus 8x plus x minus 7x. Yeah, okay. Okay. Okay, so at this point, we're going to say x cannot equal what? Negative 2, negative a half, and 4. Just going to keep that in mind. That's going to come into the domain in a second, right? But when you do this, I like to state the restrictions on it as soon as you do, just so that they're there. Okay. Okay, so we've got nothing on the top, right? And x plus 2 down here. Oh, yeah, because there's a 1 up here, right? I know some of you like to, oh, maybe I should put as, no, it's a 1. Go to 1. So whenever you cross something off, write a 1, right? So up top, we got 1 times 1. On bottom, we got an x plus 2. Here's our restriction. So it's 1 over x plus 2, and what's our domain? X is not equal to negative 2, negative 1/2, and 4. That's where you probably don't want to use interval notation, right? Because now you can write like 3 intervals, right? Negative infinity to negative 2 with round bracket, and negative 2 to negative 1/2 with round brackets, and negative 1/2 to 4 with round brackets, and 4 to infinity.
Why was it plus minus?
Why was what plus minus? This one? You get 2x plus 1 and 2x minus 1. Okay. Questions? No? We're all good? Complete the following table. Okay, so this is B, it's part of above. So G of X over F, I think we did that one, right? G of F, where is it? There it is. G of X over F of X. Simplified form. All right, I got to get this because it's on a different page. So the simplified form we found was x minus 4 over 2x minus 1. The non-permissible values we found are plus or minus 1/2. Okay, let's change that to restrictions. Right, because non-permissible values, I'd have to write x equals. So they're really restrictions, right? X cannot equal. It's better to state it that way, right? Don't put in a half or negative a half. Vertical asymptotes. So where do we get a vertical asymptote? At the restrictions, right? So the plus or minus 1/2. Did that disappear? Yeah, I know. It should be there as well. So, oops, wrong way. So we have vertical asymptotes at x equals, oh wait, it's not both plus or minus a half, is it? Because, hang on. The vertical asymptote only occurs here in the simplified form, right? The other one is what?
The point of discontinuity.
Point of discontinuity, right? So when we had the 2x plus 1, that's a point of, because it canceled out, right? Okay. So vertical asymptote, x equals 1/2. Equation of the horizontal asymptote. Okay, get rid of these, make x really big. I'll just get rid of the x. What do we got? 1/2. Okay, but it's an equation, so what about this half? Okay. So it's horizontal asymptote is y equals 1/2. Okay, you're starting to remember that. Wait, we did this stuff. I've seen this before. In another life, it seems, right? That was a long time ago. Points of discontinuity. So we say, okay, you go back to here, and you say, okay, what did I cross off? This is the point of discontinuity, right? 2x plus 1. So x is negative a half. So x equals negative a half. Now, if we want to find that point, we say, well, you can put negative a half into here. It's just fine, right? And when we put negative a half into here, we're going to get the y value of the point of discontinuity, right? Okay, so we've got negative 1/2 minus 4 over 2 times negative a half minus 1. So 4 is 8 halves. This will be negative 9 halves. And that's negative 1 minus 1 is negative 3. So it's negative 9 halves times, now right there, I like to write it as a fraction. Right, negative 3 over 1, so that I can multiply by the reciprocal, right? Flip this. So that's positive 3 halves. So the point of discontinuity is at negative 1/2, 3 halves. Okay, so if we're graphing that, we have to. Yeah. I'm looking at the key here is wrong. I mean, unless you want to tell me this is wrong. Tell me this is wrong. Okay. The key I'm looking at is wrong. Hey, Emma, the key is wrong.
2 times a half is 1.
2 times, oh, see, then I'm wrong. The key is right. So that's negative 2. Okay. I wanted to stop him, but I was going to apply the brakes, but I was afraid. Don't be afraid. Say it. It's the worst. You're wrong. I'm wrong. Am I afraid? Embarrassed? Yes. Afraid? No. Negative a halves times 1 over negative 2. So what is that? 9/4. I got the answer in front of me. I got it wrong. I mean, how good is that? That's why I paused. I said, wait a second. What's the x-intercept? Yeah, set y to 0. Like, forget this, right? I just need this to be 0. So set y, then x is 4. X-intercept is 4. What's the y-intercept? Okay, so set x to 0. So it's 0 minus 4 over 2 times 0 minus 1. which is negative 4 over negative 1, yeah, which is 4. Draw the graph. All right, so we have an asymptote at 1/2. Right, 1/2. We have a point of discontinuity at negative 1/2 and 9/4. That's now 9/4. We have a y-intercept of 4 and an x-intercept of 4. It's a rational, so it's going to look like this. Nice arrow. And on this side, oh, we've got a, what do we say, y equals 1/2? Horizontal asymptote. Okay, so that's at 1/2. And we're going to get something that looks like this. Wait, sorry. Goes through 4. And then up.
That means shouldn't the at the bottom be wrong? Should be under the horizontal asymptote?
Why, how could it be under? It can't be 1/2, right? So you're saying like it
No,
crosses.
the other one.
Oh, the other one. You're right. Good catch. Okay, this video is not going to be posted. Too many. Oh, it's fine. Who cares? And somebody already commented on one of my other videos and said, "This didn't help. You suck." but it was written as all one sentence. Like, this didn't help, comma, you suck. Right? It would say this didn't help, and then you suck. This didn't help, you suck. It's good. It's designed to help you, not suck. So this didn't help you suck is actually a good comment.
People suck.
Like, if they're going to write that with poor grammar, I'm going to take it the way it was written. All right, g over h of x. So that was, the simplified form was 1 over x plus 2. The restrictions were x is not equal to, so you could see it, it's right above, right? Negative 2, negative 1/2, and 4, right? It's not right above for me, so I can't see it. The equation of the vertical asymptotes, so the vertical asymptotes is what's left on the bottom, which is just this guy, right? So it's x equals negative 2. The point of the equation of the horizontal asymptote, so we've got 1 over an extraordinarily large number, which is nothing really, right? So it's y equals 0. So it's not that there isn't one, it really is nothing, it's 0. And point, or points, in this case there are points of discontinuity, right, because we had two things cross off. So the first one was where? At x equals negative 1/2. Okay, and we're going to substitute, I'm just going to copy it off of this. So in this case, y will equal 1 over negative 1/2 plus 2, which is 1 over 3/2, which is 2/3. So we have negative 1/2 and 2/3. Comma 2/3, right? Okay, and the other one is where x is equal to 4. So we get 1 over 4 plus 2, which is 1/6. So we get 4 comma 1/6. So 2 points of discontinuity, negative 1/2, 2/3, 4, and 1/6. The x-intercept, none, right? You can't make this 0, right? Because it's got a 1 up top, right? And that's the horizontal asymptote anyways. So the x-intercept or intercepts, there are none. Y-intercept, you set x to 0, so y is equal to 1 over 0, what is it, plus 2? So 1/2 is the y-intercept. And now you draw the graph. So we have a vertical asymptote at negative 2. We have a negative 1/2, 2/3, so that would be about negative. There's a point of discontinuity. That's negative 1/2. This is 2/3. And we got another point of discontinuity at 4 and then 1/6. So, okay, that's 2. And here's 4. And there's 1/6. Okay. So we're going to come down here, along here, but not go through there. And not go through there. This goes up. And on this side, just like so. So the aim is just to finish the next page, I guess, right? The aim to finish the next page. Number 4, so we'll do 4 and 5. If f of x is x minus 1 over x squared plus 4x plus 3, and g of x is this, determine the simplified expression for each of the following functions and state the domain. Okay, so f of x minus g of x, right? So this is equal to x minus 1. All I'm going to do is just factor the denominator, which is what? X plus 3, x plus 1, minus, and this guy's x plus 1, x minus 5, x plus 3. Okay. Why is it important to check your factorization?
Otherwise, everything.
Yeah, everything below that's just going to be wrong. If you don't find, see here we've got x plus 3 common. If you factor it wrong, you're going to end up with 4 different denominators. The expression is just going to get way more complicated, right? There should be 3 terms in the denominator, right? We need a common denominator here. It's going to have 3 terms. If you have 4 terms, you're cubing stuff. You need to stop if you do that on a test, right? And as soon as you start saying, wow, I'm getting cubes, stop. Okay, you messed up. So our common denominator, okay, now restrictions are what?
It's going to be -1, -3.
Okay. So then what do we have here? X minus 1 needs what? It's got this and this, so it needs an x minus 5. And the x plus 1, that's got the 5 and the 3, so it needs an x plus 1. Okay. Now we just gotta. We got x squared minus 6x plus 5. So I like to put them in brackets, right? That'll just remind me. I'm not going to remove the brackets, but I'm just going to remember when I go to do this. I'm going to go, oh yeah, it's minus x squared minus 2x minus 1. Okay, x plus 3, x plus 1. Okay, so we get x squared minus x squared, negative 6 minus 2x would be negative 8x, 5 minus 1, that's plus 4.
So you can take off.
Now, we would say to ourselves, hey, you can factor the negative 8x plus 4. And so I say to you, you should do that if you can cancel one of your factors with the stuff on the bottom. Can you, if you factor out the... No, right? Because you're going to have 4 and then negative 2x, or you're going to have negative 4 and then a 2x. So if you factor the top, you're going to have a 2x. There's no 2x's on the bottom. Don't do it. Okay? You don't need the factored form of the numerator. So you do want to factor the numerator if you're going to end up canceling one of the factors with the denominator. Otherwise, you don't. So we just stop here. Right? And then we state our domain. And what do we, well, it's just these guys, right? Negative 3, negative 1, and 5. So that's the simplified form, right? Negative 8x plus 4 over x plus 3 times that. And don't multiply the numerator out, or sorry, the denominator. Just leave it. All right, we're okay with you just leaving it. Okay, 4b. Oh, really? Like division? All right, so what do we do if we're dividing? So what's x? Multiplied by the reciprocal, right? So that's f of x times, okay, well, we've already done the g of x, right? But we're going to flip it. So x minus 5, x plus 3 over x plus 1. Okay, so g of x, that's the factored form, but we're dividing by g of x, so we multiply by the reciprocal. What are my restrictions? So we've got -3, -1. What else? There's one more. The 5, right? Because the 5's down here. So it can't be 0. Right? In g of x, just here's g of x. In g of x, you can't have a 5. Okay? In this, you can. But you can't because we're dividing. And you can't divide by something that's undefined. And g of x would originally be undefined. Right? Okay. So, now what? Well, we could cross off an x plus 3. And that's about it. Suppose we can write that as an x plus 1 quantity squared. And we can multiply this out. And your domain is x can't be -3, -1, or 5. Okay, one more. And we'll be done. Class will be over and you can say, well, big thing about you're not going that far. If f of x is equal to, now we get radical, and g of x, then determine the simplified expression for each of the functions and state the domain. Okay, so what do we know about domains right here?
X must be greater.
So right off the bat, looking at these, we'd say, I know x has to be greater than or equal to 0. Now, if I'm just going to multiply by 3 and multiply by 2 and add them, I'm not really going to change the domain any, right? So that's going to be our domain. So this is 3 times 4 root x plus 3 plus 2 times 2 root x minus 6. So that's 12 root x plus 9 plus 4 root x minus 12, which is 16 root x minus 3, and the domain x greater than or equal to 0. Okay, so you do f minus g of x. That should be pretty easy, right? So just bracket things so that you'll remember to apply distributive law. If you like to, remove on the next line, remove the brackets, just change these signs, and then collect the terms. Okay, so depending on your level of comfort with stuff. Two more. Do not speak. Is that right? Good. So we're all just checking our foiling skills with radicals. Now we get to rationalize. So and what's the bottom? 2 root x minus 6. The conjugate. So the exact same two terms, but with the opposite signs, right? Which sets up sort of a difference of squares, which basically means that it's a square minus a square, so that there will be no radicals remaining. So up top, I think we get what we just got. Can we? Yeah, we already did. Oh, no, it's a plus. Okay, so it's close. So it's 8x plus 24 plus 6, so plus 30 root x plus 18 over minus 36. And what can't x be? Well, it's got to be greater than or equal to 0 because it's a radical, but then looking here, x can't be 9. So here's the question. Can x be 9 in here?
Yes.
No.
No.
So what's the root of 9? 3, 2, 6, minus 6. Or so it can't be, it couldn't have been, we really would have had to actually take, if it didn't come out in the wash here, that's something we should have noticed up there. We went through this discussion, it was like in a 20 class, and I think we had something like 3 minus root x was in the denominator, right? So you say, well, x can't be 9, but after you rationalized it, you now had 2 restrictions. So you introduced a brand new restriction, which wasn't a restriction in the original. I think it was something like this, really. But whatever. Restrictions should always be on the original function. So if you introduce new restrictions, you should be aware of that and then not restrict that. Okay. Or make some statement like this is not a restriction in the original. Done.